Hey, I'm Rob, and Todd's over here, and we're doing our indeterminate system. Uh, um, what is this? Cylinder, couple inset cylinders, um, applying force on each other. So basically, we have four cylinders. Each one is made up of a different material, and we're trying to find the strain on this fourth one here in the middle. So, um, Todd, you want to grab the camera so that we can actually see the variables when I write them on the board? Okay. So for our first equation, we know that we have to solve this for statics.
Does it look good?
Yeah, that's fine. Okay, so for our first equation, you're probably going to want to point more this way so that you can see what I'm writing. Anyway, so for our first equation, we know that RA plus RB is equal to F plus RC plus RD. So that's sum of forces. So these forces are going right, these forces are going left. They offset each other. That's our first equation. Second equation, we have to account for each of these
Force displacement equations?
forces. Yeah. So that means that we have delta 1 is equal to RA F1, where delta is the strain, right?
Yep, it's a change in length.
Yeah, it's it's the change in length of the piece, and then RA is the reaction force associated with it, and then F1 is the flexibility. So there's that equation, and then delta 2 is equal to RB F2, delta 3, that's a crappy delta. Delta 3 is equal to RC F3, and finally delta 4 is equal to RD F4. All right, so that's those equations. Then finally we have some compatibility equations. That's our third set of equations. So we know that the displacement of the first one is going to be equal to the displacement of the second. And we know that the displacement of the third is equal to the displacement of the fourth. And then finally, displacement of the first is equal to the opposite of the displacement of the third, which is also equal to the opposite of the displacement of the fourth. And then
Same goes for delta 2.
same goes for delta 2. It's also equal to negative delta 3 is equal to negative delta 4. All right. So these are equations for compatibility. So now we're trying to solve for the change in length of this piece right here. So that means we need to find out what this is. So delta 4, we're going to start with delta 4 is equal to, or we're going to start with an equation that has delta 4 in it. So that means that RD is equal to F4 over delta 4. Or other way around. Excuse me. Delta 4 over F4. So, and then RA is equal to delta 1 over F1, right? So, but we know that delta 1 is equal to negative delta 4, so we're going to replace that with negative there, 4 there. So negative delta 4 over F1 is equal to RA. So RB is equal to delta 2 over F2. We know that delta 2 is equal to negative delta 4, so we're going to make that substitution. And then RC is equal to delta 3 over F3. And we know from this equation that delta 3 is equal to delta 4, so we're going to make that switch. All right, so now we have an equation for RD, RA, RB, and RC. So we're going to plug those back into this equation up here. So we got negative delta 4 over F1 minus delta 4 over F2 equals F plus delta 4 over F3 plus delta 4 over F4. Oops. All right, so all that's left to do is we know all of these other values except for delta 4, so what we're going to do is we're going to add these over here and move the force back over here. So we got negative F, or negative F times hold on. I have to do some funky math here.
Just do it all in
Yeah.
steps.
Here, so hold on. So F equals delta 4 times the quantity 1 over F1 plus 1 over F2 plus 1 over F3 plus 1 over F4. Okay? So, we can convert this into a fraction where it's all, let's see. Oh yeah, now I remember. So this is equal to negative F equals delta 4 times the quantity F2, F3, F4 plus F1, F2, F3, F4, and then F1, F2, F4, and F1, F2,
Rob, can the camera see what you're writing?
F3. I don't know. Yeah, I think so. Move it closer a little bit so they can see. Okay, so all of
Plus
those,
signs.
right? And then that's all over, yeah, plus, plus, and there's a plus there. That's all over F1, F2, F3, F4, right?
Mm-hmm.
Okay, so now we divide the whole thing by all these F's. So it's kind of a pain. So I'm going to move it over here. So we got negative F all over, or negative F times little f1, f2, f3, f4 divided by the quantity f1, f2, f3,
F4.
f4 plus f1, f3, f4 plus F1, F2, F4 plus F1, F2, F3. And that's all equal to delta 4. So now we can plug in our values, which are over here. And we end up with an answer that is
We haven't calculated it yet.
butt ugly. So give us a second, because we're going to calculate it. Okay.
We can stop the tape during here. That's
Actually, yeah, we can. So we're going to stop, and then we can do it. Yeah, that's fine. We don't need to write anything else. All right, so we did the calculation, and the number we got is negative 7.79 inches is equal to delta 4. So that means that this guy over here is in compression. It's going to displace negative 7.79 inches that way. So that's our indeterminate system, and say that's all we got. So there we go. All right, there we go. We're done.
painful.